This is a video presentation of Chapter 5, Section 7 in the 8th grade textbook entitled Indirect Measurement. So we're kind of putting a few different paths together here. We've been talking about similar figures. We've been talking about the concept of dilations. Really, this section is about those. We're talking about shapes that really are somehow dilated, are somehow similar. That's going to be a given. Whereas in the last couple sections we had to prove that this was the case. Now all of a sudden they're saying that this is a given. What they're going to ask us to really be working on here now is, since that's given, find whatever missing length they want to throw at us. So this is really more back towards the idea of solving the proportions, figuring out if ratios are equivalent. But again, all these topics have merged together in the last few days, so this is really more along the path of what we've been doing, just another topic in that area. So indirect measurement is a way of using similar figures and proportions to find a measure. A way of using similar figures and proportions to find a measure. One of the things that's going to be vitally important here for us in almost all of these is a drawing of some type. Drawing out the scenario they give us, or a drawing of that might already be there for us, and using that picture, creating a similar orientation so we can see how things match up. And that's exactly what they're showing us here in number 1. So let's go ahead and start looking at number 1 here. It says that the triangles are similar, triangles named A, B, C, and E, F, G, and we're supposed to find the length of side EG. Now remember, that letter order is important because that letter order tells us the way that the angles match up here. For instance, the first letter here is A and the first letter here is E. So that means A and E should look the same in terms of the angles. These are both 90-degree angles. So that makes good sense. Remember, in similar figures and dilations and whatever you want to say here, those angles still have to be the same. No question. Again, we're already telling you though that these are the same. But if we don't have them oriented the same way, you would want to now take some time and redraw here. Notice these are both oriented the same way. For instance, this right angle is at the lower left of the drawing. But again, if this triangle is kind of turned around here, such that the right angle was maybe up here, I would turn the drawing around and redraw it, such that it's the same as this one. Okay, so we're trying to find the length of side EG that's marked with an X here. So what they've decided to do is to set up a little proportion. They're comparing EG and AC. Well, how are they getting away with that? Well, notice that these are both the bottom of the shapes. And they're comparing that to EF and AB, and notice that those are both the left sides of the shapes. And notice the way they've set up our proportion. We've talked a lot of times about consistency. Well, notice here when we're talking about this proportion, what's across the top comes from what I would call the big triangle, the one on the right. What's across the bottom there comes from the small triangle that's on the left. And notice this letter order here also matches up to the letter order up here. EG first and last, AC first and last. So not only can we see that they're both the bottoms, but we can see they match up with the letter order up here. So now what they do is they change those into the numbers they represent. For instance, it says here that EG is X, and it says that AC is 4, and it says that EF is 9, and it says that AB is 3. And now we're going to solve the proportion here. Well, we know on the one diagonal, 9 and 4 there has to make 36, which means the other diagonal, 3 times X, also has to be 36. So I'm saying, what do I multiply by 3 to get to 36? Well, 3 times 12 is 36. So that means X must be 12. And our missing side EG then has to be 12. So the length of side EG is 12. Now, perhaps that's too much work for you. A lot of steps, a lot of writing involved here. We can make this a lot simpler. Let's come back up here to the triangles. All we have to do is insert some fraction bars and an equal sign to show the proportion I'm going to solve. When I come over here to this triangle on the right, the two things I have are the left side and the bottom side, the 9 and the x. So what I'm going to do is I'm going to stick a fraction bar in between those guys. And what you want to do is insert a fraction bar in the other triangle the exact same way. Now there's a catch. The triangles have to be drawn with the same orientation. But if you remember, I said right in the beginning that that's something you should do anyway, is you should draw them so they're set up the exact same way. So if I insert a fraction bar the exact same way, it's going to be like this. Well, now I'm just going to set those two guys equal to each other. 3 over 4 equals 9 over 12. Now you're saying, well, wait a minute, that's a little bit different than what we got. Or, sorry, instead of 12 here, this should really say x.